Welcome back. We're on homework 3 for thermodynamics at South Dakota School of Mines and Technology. This week's topic is partial molar properties. That's pretty much it. And so, we have a mix of analytical problems in addition to the graphical problems. So on the analytical ones, we'll just do the math, but on the graphical ones, I'll try and draw the picture as best I can. Okay, so in any case, the first one says for the following equations, so we got partial molar V1 is equal to C plus P squared A plus BX squared 2. And partial molar V2 is equal to C minus P squared A minus BX1 squared. Okay. So the following, develop an expression for V1, V2, V, and delta V mix. Okay. So let's do that part first. All right. Well, I have to remember what things mean. So, again, this kind of all goes back to numeracy, and what do the variables mean in words? What does the math mean in words? Okay. And when I read this, it tells me, okay, this is how much component 1 contributes to the total volume of the mixture. Okay. Now it says, develop an expression for V1, V2, blah, blah, blah. Okay, well, little v1 says that is the molar volume of component 1 as a pure system. Keywords, as a pure system. As a pure system. Meaning pure, meaning that there is nothing else other than whatever it is. And what is it? It's component 1. So if there's nothing but component 1, well, what does that say in terms of the math here? It says, does it say anything about C? C being some constant? No, it's constant. Okay, what is it? What about pressure? Okay, does it being pure have anything to do with the pressure? No. The only thing that it impacts are my mole fractions, which are my x2s, my x1s. Okay. Now in terms of V1, okay, this one right here, does that have anything to do with partial molar V2? Does the volume of component 1 as a pure system have anything to do with how 2 contributes to the volume of the mixture? No. So I don't care what's going on with this one, I just care about what's going on with this one, okay? But it's pure, which means there is only component 1. And how is mole fraction defined? Well, the percentage of the mixture. So in this case, x1 goes to 1. Well, there's no x1s in there. So what do I do? Well, this is a mixture. How, if x1 goes to 1, how much x2 is there? Is it just x2? No! x2 is 0. If there's all of it's 1, then none of it's 2 or 3 or 4 or whatever. There is just component 1. And so, in terms of the math, I just plug in, and so in terms of the math, I just plug in equals 0, but like, what do I want to see in terms of work? Okay, this is what I want to see in terms of work. So, partial molar V1 goes to V1 as x1 goes to 1. And x2 goes to 0. Okay. And then I, plug in my work. And so I got C plus P squared A plus B 0 squared. Okay, and I want to see that. I don't want you to just eyeball it and say C plus AP squared. I want you to show me that you know what you're doing by plugging in the numbers. Okay, and then yes, I get, C plus AP squared. That's equal to E1, and then I'm happy. But show me this. Show me this. Show me this. It all has meaning. Okay, and it shows me that you understand what you're doing, and that you understand what this math is saying. You're understanding the numeracy. You're understanding everything else. What about V2? Well, it's the same thing except for it's the reverse. Okay, so partial molar V2 goes to V2 as X2 goes to 1, and it's not that, I wouldn't write it X1 goes to 0. Okay, as a result of X2 going to 1, X1 goes to 0. Okay, so really this is the cause, this is the effect. But I do the same thing. Okay, so this means that I got C minus P squared times A minus B times 0 squared again. And so that means V2 is equal to C minus AP squared. Okay. All right. So those are those two. Okay. Develop an expression for V. Now, I know normally you're given V and you derive all these other things, okay? But this problem is working in reverse. Okay, why is that? Well, so that you understand how everything relates to each other. That's why I put together this problem. Okay, so if I know how each component contributes to the mixture, well, I can know what is the mixture, because by definition, and I don't expect you to memorize a lot, but by definition there's a couple things I want you to memorize. I want you to memorize partial molar property definition, but I also want you to remember that V is equal to the summation of xi partial molar bi. Okay. Why do I expect you to memorize that one? Because you should be able to read the words and translate that back to math. If this is contributing this much and this is contributing this much, well, I add those together, essentially, and I should get how much they're contributing to the mixture as a whole. V. Okay, because that's what V is. The volume of the mixture as a whole. Okay. And so, what does that all look like? Well, I got this formula. Do I have partial molar V1? Yeah. Do I have partial molar V2? Yeah. Do I have X1 and X2? Well, I want it in generics, so essentially yes. So, all that V is equal to is X1 times this stuff well, that's a C. That's a big trying to get my brackets. Okay. Plus X2 times the other stuff. C minus P squared. This is the one I want to circle. Okay. A minus BX1 squared. Parenthesis, bracket. Okay. And essentially, I'm done. But I do want to clean things up. Okay. That's half the battle. Okay. But I do want it cleaned up. So I mean, like in terms of points, you would have most of the points at this point, because you would have written down this guy and you'd be written down this guy. But I do want it cleaned up, so just clean it up really quick, and it actually cleans up pretty nicely. So, so I have x1c plus plus x1 AP squared plus bx2 squared x1 plus x2c minus x2 AP squared plus, because minus minus, okay, bx1 squared x2. Okay. And then when you're combining terms, usually you're wanting to combine like the a's and the b's and the c's and stuff. Okay. So in this case, b equals, okay, let's do our AP squared, because and there should be a p squared here and a p squared here. Okay, but in any case, let's move on. So let's combine our a terms. So we have a p squared, and the reason why is because my x1s and x2s, especially in a binary system like this one, will clean up nicely, typically. Okay, so I have x1 minus x2. Okay, that's about as clean as that's going to get, most likely. But let's keep going. Maybe something will happen. Okay, but I doubt it. Okay, so we got bp squared. Okay, we got oh, and they both have an x1, x2. So x1, x2, and then I have x2, because I have an x2 squared there, and I have an x1 there. So x2 plus x1. What is x2 plus x1 for a binary system? Yeah, that's 1. Okay. And then plus c x1 plus x2. Well, we just established that x1 plus x2 is 1, so 1. So when I'm all said and done, and let's pull out our p squared, and so it kind of looks like that thing. So when I'm all said and done, v is equal to c plus p squared times the quantity a parentheses x1 minus x2 plus b. Oh, sorry, actually. Can't forget this guy. x1, x2. Okay. Now I'm good. Okay. So there's my v. Okay. All cleaned up and pretty and beautiful and blah, blah, blah. Okay. The last thing it asks for is delta V mix. Okay. And so if I look at delta V mix, well, I gotta know its formula. So we'll use green. I have a different color. So delta V mix is equal to V minus V ideal solution. And what's V ideal solution equal to? It's equal to the summation of xi vi. Okay. And did we already derive formulas for vi and v1 and v2? Yeah. Just plug everything back in. Not that crazy. Now let's kind of clean things up. I also had that v that I just erased, but whatever, I kind of remember what it was. It was like c plus a times c plus b times some stuff. Okay. So what was it? It was delta v mix is equal to, so I can do that and plug it back in. Another thing I can do, if this helps, but is remember I can write this because of what v is equal to and what v ideal solution is equal to. I can write this as summation of xi times partial molar vi minus vi. And I'm not going to do that because I think it'll be easier to just, have the equation I had, which was c plus p squared a times x1 minus x2 plus b x1 x2. I believe that looks right. Okay, minus the ideal solution. Okay, so minus x1 times, well, this one was c plus ap squared. minus, they're both minuses, don't forget to distribute the minus sign, okay? That's naughty math in a sense, but not as drastic as some other naughty math. So that does not qualify for naughty math, but it is naughty math. So just don't forget the minus sign, okay? That one's a little bit more understandable, okay? I forget the minus sign too. And this one is C minus AP squared, okay? And those B terms just go away when I have B1 and B2, okay? In a sense, okay? And now I just clean this thing up. I mean, essentially I'm done, but I need to clean it up. And this one will really clean up nicely, you'll see. So I have, again, let's distribute most things. So I have C plus AP squared x1 minus AP squared x2 plus BP squared x1 x2 minus x1c minus x1 AP squared I feel like I missed something, but we'll get there. Oh, no, I didn't. No. So AP squared minus x2c plus x2 AP squared. Okay. I was thinking I missed something, but I didn't. Because here's my APX1 minus APX1 minus APX2 plus APX2. Alright, so those just go away. Alright, let's look at our C's. So I got C of 1 minus x1 minus x2, which is equal to 1 minus x1 plus x2. And what's x1 plus x2? 1. And what's 1 minus 1? 0. So that all goes to 0. Like I told you this was going to clean up nicely. So those all go to 0. And I have B plus BP squared x1 x2. Okay, can I simplify that anymore? Well, no. That's my delta V in mixing. Okay. And well, that's my delta V in mixing. What does that mean, though? I mean, in hindsight, well, I look at this guy. Okay, so I mean, ignore this stuff because that was the V ideal solution. Here's my V. Here's my original V equation, so to speak. Well, that's my mixing term. That's what that is. Like, here's my, here's like some general fudge factor. I need at least that much volume. And then, okay, here's the contribution from component 1. And here's the contribution for component 2. Okay, because that's where these two come from. And then I have this guy, which is the component as a mixture. It's like I have my pure, my C plus AP squared. And then I have my other pure plus, minus AP squared x2. Okay. So, like, there's my pure, and here's some fudge factor associated with mixing. My packing parameter, or whatever it might be, but this is my volume of mixing. This is what happens when I bring them together. And it looks like in this case, now this is a made-up case, by the way, in this case, that I'm adding volume as I'm adding as a mixture, okay? So to speak, okay? Let's see here. So, well, there's delta V mix. Okay, so, and then it says, find V1, V2, partial molar V1, partial molar V2, V, and delta V mix if this. Well, I've got all these equations, I just need to plug it in. I mean, that's literally all I need to do. Plug in numbers. When x1 is this, when x2 is this, when p is this, when a is this, when, blah, 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 blah. I mean, I'm essentially done. Okay, so because I'm essentially done, I'm going to call it quits.